Welcome into the Paper 2 Touch-Ups, where we talk about the things that you need to know. In this session, we'll be talking about trigonometry, which is general solution. If you are new to the channel, just please be sure that you don't forget to subscribe so that you won't miss when another video gets uploaded. So without further ado, we're going to look into the question that I've brought you in general solution, and basically I'm going to be explaining to you what is required or what you need to know when you're doing general solution. So the question that you have here, we're given this equation here. Now, before we go into the equation, I want to talk about general solution here. So general solution, basically, you can think of it as algebra of trigonometry. So when I say algebra of trigonometry, I mean that in order for you to simplify general solution, you need to be good at solving algebra. Now, I know a lot of you might maybe disagree with this, but I know that from time to time, all the expressions that I've worked with whenever I was doing general solution, they always required me to either use factorization, right, which is where I can use trinomial, or take out the common factor, and sometimes they wanted me to use some inspection, right? So all those tools, they're just tools that you use in algebra, so it means you need to be good at doing that. But now that's not the only thing that general solution is about. General solution is basically about isolating a trig ratio. So they try to make sure that you want to end up with one trig ratio. It's either going to be sine theta, or sine of whatever angle that you call it, or cos theta, or tan theta. Because when you do that, you can then be able, right, to apply the general solution based on that trig ratio that you have solved. So in this one, we are given here, the question says consider cos 6x plus cos 2x is equal to 2 cos 4x times cos 2x. Now the first question, it says that we need to show that cos 6x plus 2 cos 6x plus cos 2x is equal to 2 cos 4x times cos 2x. So now here, this is an identity, right? As you can see here, the first thing that we're going to do here is look on the left hand side. So as you can see, the reason why I'm looking at the left hand side, because this one is the one that needs a little extra simplification. Right now here I can see I have cos 6x plus cos 2x. So let me just write this: cos 6x plus cos 2x. So here, the problem here is that I have this double angle here, 6x. I'm fine with this one, so I'm looking at this one, which is cos 6x. So now what I'm going to do here is I'm going to break that double angle into a compound angle that contains 4x and 2x, because my solution that I'm trying to get to has 4x and 2x. So the way I'm going to do it, I'm going to say 6x can be written as 4x plus 2x. Now this breaking down of an angle, it is valid because both of them are still double angles, so which is fine, right? So this then gives me cos 4x times cos 2x minus sine 4x times sine 2x, right? And then this will be plus, or did I say multiply here? No, it's plus. This will be plus cos 2x. Alright, now let's see what we have here. So here I can see that I do have my cos 4x and cos 2x, so I'm happy with that one. So I'm just going to keep this one and I'm going to focus in on the other ones, right? So this then means I'm going to drop the cos 4x times cos 2x because I'm happy with that one. And then when I get here, minus, I see I have sine 4x and sine 2x. So sine 2x, I'm going to keep that one for now. And the first thing, I'm going to expand this double angle here. So expanding this one is going to give me 2 sine 2x times cos 2x. Then I'm going to say times sine 2x plus cos 2x. Now, how did I get into 2 sine 2x times cos 2x? This is what I did. If you remember, sine 2 theta, or let me just write 2x since I'm working with x. Sine 2x is 2 sine x times cos x. Now here, if you're looking at this trig here, you can see that here this is a double angle, but the angle that is obtained there, it is half of that one, right? So if this is 2, this is going to be 1, right? If that is 4, it means that's supposed to be 2, right? If this is 4, then those are supposed to be 2. hence I got that answer there. Then now here I can see that this and that, so I have this cos 4, so I have this cos 4x times cos 2x. I just want to write it one more time just to see clearly what is happening here. Oh yeah, I see here sine 2x times sine 2x, it is sine squared 2x times cos 2x plus cos 2x, right? Now I see there's a common factor here. I see something common, this, and that, right? So let's go ahead and take that one as a common factor, cos 2x. So taking that one out, I am left with cos 4x, right? Cos 4x minus 2 sine squared 2x plus 1, right? All right, and then now here I can see that here I have 1 minus sine squared 2x. So this is, let me just simplify this one more time. This is cos 2x, and then this is cos 4x, and then if I simply work with this one, this is going to be plus 1 minus 2 sine squared 2x, right? Now this gives me cos 2x into cos 4x, and then now this one here, you can see that this is a double angle for cos, right? Now this one, it came from this idea. Remember cos 2x, remember cos 2x can be 1 minus 2 sine squared x, remember in the previous video. And then now here this 2, this is half. It means now if here is 4, this is supposed to be what? Cos squared 2x, right? Hence now what we're going to do here is that 1 minus 2 sine squared 2x, we're going to change it into a plus cos 4x, right? Now add these two, cos 4x plus cos 4x gives you what? It gives you 2 cos 4x, and then you multiply that one out, and then your answer is going to be 2 cos 4x times cos 2x. And then as you can see, when simplified, it gives you the right hand side. So this basically means that this is the same as that one. So let's go ahead and look into the second one. Now the second one is the general solution, where it says now hence otherwise write down the general solution of the equation. So here this is the general solution of the equation that we're given, but now if you're noticing here, the first two terms are exactly the same as the ones that we were doing here. You see here, cos 6x plus cos 2x, cos 6x plus cos 2x. So this then means now the first thing that you need to do is you need to change that one and write it as this one, because basically they are the same thing. So first thing that I can do is I can say cos 4x and cos 2x. Now why do I say that this is the first thing that you need to do, right? This is because the question started by saying hence otherwise. So with the minute it says hence otherwise in trigonometry, that you should know that that's a hint that you're supposed to use what's in the previous question or what you just answered. So even if you didn't get this one right, you're still gonna get a chance to do your general solution easier, right? Because you're gonna use this one, right? So now here I can see now I have these two terms. Like I said, algebra, I can see these two terms is a common factor. So the common factor here, it is cos 4x, and then I'm left with 2 cos 2x plus 1, okay, square bracket, equals to 0, right? So this is a factor and that is a factor. So this basically means that cos 4x is equals to 0, or I'd like to write this one at the top there, 2 cos, because I don't want to disturb them, 2 cos 2x plus 1 equals to 0, right? Now here I want to start with this first one. So starting with this first one, I can see that my reference angle here, my reference angle is going to be cos inverse of 0. So cos inverse of 0 gives me 90 degrees. And then now because of I have my trig ratio equals to 0, that means if I want to do my general solution, I can just look at quadrant 1 and quadrant 2, or even better, I can look at quadrant 1 and another quadrant that won't give me the same solution here. So let me just take the one where it's positive and the one where it's negative, right? So the one where it's positive, it is quadrant 1, right? So in quadrant 1, 4x, right, is equals to reference angle, which is 90, plus the period of course. So the period of course is 360k, where k is an element of integers. And then if you divide by 4 everywhere, you get that x is equals to 90 divided by 4 gives you 22,5. And then 360 divided by 4 gives you 90 plus 90k, and that is the general solution for the first quadrant. And then let me look for the other quadrant, which is basically quadrant 3, where it's negative. So quadrant 1, we chose it because we saw it's positive, it can be positive, and then here it can be negative. And the reason why I'm choosing positive and negative is because 0 is neutral, right? So because of 0 is neutral, I can choose any, right? Neutral. Let me just write it, neutral. All right, so let's look at the third quadrant. Third quadrant says 4x is going to be 180 plus your reference angle, which is 90, plus the period, 360k, where k is an element of integers. Oh, that's so wrong. Integers, all right. And then this means now here 4x is equals to, now 180 plus 90 gives you 270 plus 360k, and divide this by 4, divide by 4, divide by 4, and then x becomes now 270 divided by 4 gives you 67,5 plus 90k, right? Now we're done with this one. That's the general solution for this solution, for this case here. Now the second case here, we're solving for cos 2x first. We're going to see that cos 2x is equals to minus 1 over 2. Now you see here we've got a solution that is negative. So where it's negative, it then means now what you need to do whenever you see this answer negative, this part tells you where you're going to apply your general solution. So negative means we're going to apply where cos is negative. So cos is negative in Q2 and Q3. All right, so let's go ahead now and calculate our reference angle. Now our reference angle is going to be cos inverse. Now when you write here, remember here we said cos inverse 0, and then here when you write this inverse here, remember the negative has already worked, so you won't write it as cos inverse negative 1 over 2, but you're going to write it as 1 over 2. Why are we doing it as 1 over 2? Because this sign right here only tells us where we should apply our general solution. If that was positive, it means we're going to look for the areas or quadrant where cos is what is positive. It's negative, it means we look for where cos is what is negative. So we've already worked out that sign, so it has already done its job, which then means now what you're going to do here, I'm going to say cos of the inverse gives me 60. So it gives me 60 degrees. So it means now here I'm looking to quadrant 2. So in quadrant 2, the solution is going to be 2x equals to, now quadrant 2, the reduction there, it's 180 minus the reference angle 60 plus 360k, where k is an element of integers. So this means now 2x is basically 120 plus 360k. Then when you divide by 2 everywhere, you get x equals to 60 plus 180k. Now in quadrant 3, it says 2x equals to, the reduction is 180 plus 60 plus 360k, where k is an element of integers. So this then means 2x is going to be equals to 240 plus 360k, and then divide by 2, divide by 2, divide by 2, and so x is going to be 120 plus 180k, and that is basically all for the general solution. Now again, the idea into finding a general solution, it is to always be able how you can use algebra into your trigonometric equation or expression, right? So if you like the video, just make sure that you share with your friends, and then if there's anything that you would like to say, please leave it on your comment and I'll be able to answer you. And I'm going to see you on to the next one, where I basically show you how you can simplify without using a calculator.